Hey guys, and welcome back for another functions lesson. Today we're looking at functions and their inverse functions. I hope you joined us for our previous lesson on functions. If not, I'm linking it down below for you, so check that out before you come back here, and let's get into it. What is the inverse of a function? Well, a function performs a set of operations on some given input value. So suppose I start with the value a. I put a into function f, and I get an output value. Let's call that b. The inverse function will undo these operations. So take b, put it into the inverse function, and you get a out of it. And we're back to where we started. So for example, if I start with the function f of x, which performs two operations on my input value. It takes x, it multiplies it by 2, and then adds 3 to that answer. I want to undo these operations. So let's follow these steps. First, for slightly easier notation, I'm just going to write y instead of f of x. Y equals 2x plus 3. And because I want to write the inverse function, I'm going to swap my variables around. Instead of y, I'll write x. Instead of x, I'll write y. Now, let's make y the subject. And by doing that, remember, we're undoing the operations. Instead of adding the 3, I take it to the other side and I subtract the 3. Instead of multiplying by 2, I take it to the other side and I divide by 2. Now that I've got y on its own, y is the inverse function. So I could write, instead of y is equal to x minus 3 over 2, f inverse of x is equal to x minus 3 over 2. Note the notation here. F with a little power of -1 doesn't mean f to the power of -1. That's the inverse notation of function f. Just as f of x doesn't mean f times x, it means function f has got an input of this x value. So make sure you don't get that notation confused with function notation. Now that we've clearly defined the f function and its inverse function, let's try inputting some values into both of these functions to see what kind of relationship their domains and ranges have. Remember, the domains are the input values and the ranges are the possible output values. The focus of this lesson is not to learn how to input values into functions. So if you need a lesson on that, make sure you check out my Intro to Functions lesson on input and output values. If I input -2 into this function, I would do 2 times -2, which is -4, plus 3 would give me an output value of -1. If I substitute 0 into this function, 2 times 0 is 0, plus 3, that's 3. If I input 2 into this function, 2 times 2 is 4, plus 3 is 7. And if I input 4 into this function, 2 times 4 is 8, plus 3 is 11. So I've got a set of output values that go along with these input values. Since the inverse function reverses these operations, the range of output values from function f becomes the domain of input values for the inverse function f. So I'm going to take these output values from function f and input them into the inverse of function f. You'll see why in a minute. If I take -1 and I put that into the inverse of function f, -1 minus 3 is -4, and -4 divided by 2 is -2. Notice anything? Let's try that with 3. If I put 3 into the inverse of function f, 3 minus 3 is 0, and 0 divided by 2 is still 0. Noticing anything yet? Again, if I take 7 and I put it into this function, 7 minus 3 is 4, and 4 divided by 2 is 2. Finally, if I take 11 and I put it into this inverse function, 11 minus 3 is 8, and 8 divided by 2 is 4. Notice that the outputs from my inverse function are the same as the inputs from my original function. That means that the range of output values from my inverse function is equal to the domain of values for my original function. You may remember from our previous lesson that we have some rules about values which we need to exclude from the domain of input values for a function. However, the range of output values is a little bit more complicated to work out. So now that we know how to work out the inverse of a function, we can work out the domain restrictions for the inverse function, and those will be the range restrictions for the original function. Let's go over those rules again. The two rules for function domain restrictions are that we can never divide by 0. That means that any function with a division or a fraction could never have a denominator of 0. Also, we can never square root a negative value. So any expression underneath a square root sign must always give a positive value. For example, this function f takes the input value, subtracts 3 from it, and then square roots the answer. I could substitute different values into this function. However, some of these values won't give a real output value. Let me show you what I mean. If I put 5 into this function, I get 5 minus 3, which is 2, and I square root that value, so the square root of 2. Now you could work out this value on a calculator, but it's an irrational number. It'll give you a decimal number, which you would have to round. So I'm just keeping it in third form. I'm keeping it exact, writing square root of 2. If I put 4 into this function, I'd get 4 minus 3, which is 1, and then I square root that answer. The square root of 1 is just 1. If I put 3 into this function, I get 3 minus 3, which is 0, and square rooting 0 gives me 0. But if I put 2 into this function, 2 minus 3 is negative 1. And if you do the square root of negative 1 on your calculator, you're going to get an error because we can't square root negative numbers. The square root of negative 1 is actually what we call an imaginary number. So 2 must be excluded from the domain of function f because it doesn't give me a real answer. But 2 is not the only value we need to exclude from the domain. Any x value less than 3 would make x minus 3 a negative number. So the domain of values for f must be 3 or more. The domain for the function f could be any value x, where x is greater than or equal to 3, and of course x must be a real number. So now that we know the values which can or cannot be inputted into function f, let's work out the range of values that could come out of function f. For that, we need the inverse function. So let's follow those steps again. Instead of f of x, let's put y. And now let's swap our variables. So instead of y, we'll put x. Instead of x, we'll put y. Oopsies, this should be a y. Okay, so that was just a typo. To get the y on its own, let's undo these operations. So the opposite of square rooting is squaring. There, I've got my y as I should. And then the opposite of subtracting 3, we'll add the 3. So now that y is on its own, this is my inverse function. The inverse function f is simply x squared plus 3. Now, I can square any value, whether it's positive or negative, a whole number or a decimal value, and I can add 3 to any number. So really, there are no restrictions to the domain of the inverse function. X could have any real number. And if there are no restrictions to the domain of the inverse function, this means there are no restrictions to the range of the original function. Let's show this again in our table. So if I can substitute any value into the inverse function, let's try substituting the output values from function f into the inverse of the function f. If I substitute the square root of 2 into this function, the square root of 2 squared would be 2, plus 3, that gives me 5. That's what I expected. If I substitute 1 into this inverse function, 1 squared is 1, plus 3, that gives me 4. Again, that's what I expected. If I substitute 0 into the inverse function, 0 squared is 0, plus 3, that gives me 3. Again, just as I expected. If I substitute the square root of negative 1 into this function, theoretically speaking, the square root of a value squared just gives me that value. So the square root of negative 1 squared would give me negative 1. Negative 1 plus 3 gives me 2. However, if the only way I could get an output of 2 is by using some imaginary number, there's no real number I could substitute into this function to get that output, I need to exclude 2 from the range of this function. But 2 is not the only value I need to exclude from the range. For any real x value, x squared will always give me a positive answer. A positive number squared gives me a positive answer. A negative number squared, negative times negative, also gives me a positive answer. So this result will always be positive, and I'm adding 3 to it. Adding 3 to any positive number will always give me an answer of 3 or higher. That means that the output value, or the range of values, for this function will always be 3 or higher. So if I define that range here as any y value where y is greater than or equal to 3, and y is a real number, the range for this inverse function is the same as the domain for the original function. And if the domain for this inverse function has no limits to it, neither does the range for the original function. You may need a minute to let that sink in. It's a little bit flip-floppy. So maybe pause and take a minute to think about that and hit play when you're ready to move on. Now remember those 2 rules. We can't square root a negative number and we can't divide by 0. So it seems fitting that we include an example where a function involves a fraction, because a fraction is just a division, where the numerator is being divided by the denominator. So here I've got a denominator of x plus 2. How is that going to affect my domain of values for function g? Let's try inputting some values into this function. I input the value of 1 into this function. G of 1 would simply be 5 plus 2 times 1, which is 2. So 5 plus 2, that's 7, over 1 plus 2, that's 3. So that would be 7 over 3. Or as a mixed number, that would be 2 1/3. Can I substitute 0 into this function? The denominator can't be 0, but that doesn't mean that my input value can't be 0. If I input 0 in for x, this would be 5 plus 2 times 0, which is 0. So 5 over 0 plus 2, which was 2. So 5 over 2, or 2 1/2. So that's not a problem. Can I input negative 1 into this function? If I put negative 1 into the function, I get 5 plus 2 times negative 1, which is negative 2. So 5 minus 2, which is 3, over negative 1 plus 2, that's 1. So 3 over 1 is 3. Can I put negative 2 into this function? That would be 5 plus 2 times negative 2. 2 times negative 2, that would be negative 4. So 5 minus 4, that's 1. Over negative 2 plus 2. Uh-oh, that would be 0. And as we know, we can't divide by 0. So if you tried, you get an error on your calculator because 1 over 0 isn't a real answer. So we've just seen that we need to exclude negative 2 from the domain of input values for function g. What about the range of possible values for function g? I see there's all sorts of output values here. There are fractional values, there are whole number values. Are there positive values? Are there negative values? The only way we can tell is to find its inverse function and working out what values can or cannot be included in the domain of that inverse function. So, following those steps, instead of g of x, let's write y. Now let's swap the x's and y's. And now let's rearrange this equation to get y as a subject. The easiest way to do that when we've got a fraction is always take the denominator to the other side and multiply. Expand that through. Now get your y terms to the same side. Factor out that y to get y on its own. And then send that bracket to the other side to get y really on its own. Now y is my inverse function. So the inverse of function g is 2x minus 5 over 2 minus x. Again, I've got another fraction here. And remember, fractions are just divisions. We can't divide by 0. So what values do you think we need to exclude from our domain? I can input all of the output values from the previous function. If I input 2 1/3 into this function, I get an output of 1. Go ahead and hit pause and try it if you don't believe me. If I input 2 1/2 into this function, I get an output of 0. Again, feel free to substitute that in for yourself. If I input 3 into this function, I get an output of negative 1. Notice I didn't bother inputting 1 over 0 into this function because that's not a real number. And if I need to use some unreal number in order to get an output of negative 2, negative 2 must be excluded from the range of this function. So my range for the inverse function of g needs to exclude the value negative 2, just like the domain for the original function excluded the value of negative 2. But what about the domain of values for this inverse function? Again, it's a fraction, and we know that we can't divide by 0. That means that 2 minus x can't be equal to 0, which means that x couldn't be 2 because 2 minus 2 would be 0. So if I substitute 2 into this function, I would get an answer of 2 times 2, which is 4, minus 5. That's negative 1 over 2 minus 2 is 0. Negative 1 over 0, again, is not a real number. So we exclude 2 from the domain of the inverse function. And whatever we exclude from the domain of the inverse function, we need to exclude from the range of the original function. So the range of values for g could include any y value where y is not 2 and y is a real number. Now, before we go on to the practice exercise, remember those two rules again. We can't divide by 0, and we can't square root a negative. And the values we can't put into the function are excluded from the domain. The values we can't put into the inverse function, we exclude from the range. Now, I hope you're ready to show me what you got. For these 4 functions, I need you to work out the inverse functions, and then identify any values which need to be excluded from the domain or range of any of these functions or their inverse functions. Go ahead and hit pause now. Take your time to work that through carefully, and hit play when you're ready to take it up. It may be tricky, but I hope you took the time to try that for yourself, because here come your answers. For question 1, let's find the inverse of function f. So let's first set it equal to y. Let's swap those variables, and let's rearrange to get y on its own. Minus the 5, divide by the negative 3. Now, this looks a bit funny with these negative signs. So if I want to make that 3 in the denominator positive, let's multiply both top and bottom by negative 1. That is, change the signs of all terms. And again, if you feel a little uncomfortable with having a negative term in front of that positive term, let's just swap those around. So make it positive 5 minus x. That looks better. Now let's get rid of that square on the y. And y is now on its own. Y is now the inverse function. Now I didn't really see anything wrong with function f. There are no fractions there, and there are no square roots there. However, the inverse of function f has got the square root sign. And I know I can't square root a negative value. So this expression cannot be negative. And it's 5 minus x over a positive number. So basically the numerator can't be negative because a negative value divided by a positive would be negative. So 5 minus x must be either 0 or higher. That means x can't be any bigger than 5 because 5 minus 5 would be 0 and 5 minus a value greater than 5 would be a negative number. So let's exclude x values greater than 5. If the domain from the inverse function excludes values greater than 5, then the range from the original function must exclude values greater than 5. So I would say that the range of values of function f must be less than or equal to 5. For question 2, I hope alarm bells are ringing when you see this g function. There's a square root sign, and we know we can't square root a negative value. So 2x plus 1 must be greater than or equal to 0. That means that 2x must be greater than or equal to negative 1. And x must be greater than or equal to negative a half or negative 0.5. So there I've got my limitations to my domain of function g. The domain must exclude values less than negative 0.5. Let's find the inverse function. Let's swap our x's and y's. Let's rearrange this to get y on its own. Opposite of square rooting is squaring. Subtract the 1, divide by 2. Now y is my inverse function. Now I see a fraction here. However, this fraction will never have a 0 in the denominator because the denominator is 2. So I can square any value, and I can subtract 1 from that value, and I can divide by 2. So the inverse function of g of x has no domain restrictions. So the original function g will have no range restrictions. On to question 3. I've got another fraction here, but the denominator is 5 and it would never be 0. So I have no worries about restrictions for my domain of function h. Let's find its inverse function. So let y be the function h. Let's swap our x's and y's. Let's rearrange to get y on its own. So multiply by 5, subtract 7, divide by 3. Y is on its own, so y is the inverse function of h. Again, I've got a fraction, but the denominator of this fraction will never be 0. The denominator is 3. So I could input any value I like into the inverse function. I could input any value I like into the original function. So neither function h nor the inverse of function h have any domain or range restrictions. On to question 4, and it's an interesting one. Let's find the inverse of function j. So let's let y be equal to the j function. Let's swap the x and y's, and let's rearrange this to get y as the subject. Multiply the denominator across, expand that out, get the y's together on the same side, factor the y out to get the y on its own, and take that bracket to the other side and divide. Now y is on its own, y is the inverse function. However, those negatives are confusing me a bit. So I'm going to do as I did before. I'm going to multiply both the numerator and denominator by -1, which will change the signs of all of those terms. Now let's just swap the terms in the denominator around to start with the positive term. So we've got x plus 1 over positive 5x minus 1. Now y is on its own. Y is the inverse function of j. So the inverse function of j is x plus 1 over 5x minus 1. Yes, you saw that right. The function of j and the inverse function of j are the same. That's going to get really interesting when we start looking at composite functions. Watch out for that lesson. It's going to be a really fun one. Since these functions are the same, they've got the same restrictions on them. They're both fractions, and as we know, we can't divide by 0, so the denominator of those fractions can't be 0. That is, 5x minus 1 can't be 0, which means 5x can't be 1, and x can't be 1 over 5, or 0.2. Since this is the case for the domain of function j, as well as the domain of the inverse of function j, both the domain and range for function j must exclude the value 1/5. So I could write that as x for the input value for the domain could not be equal to 0.2, and j of x, the output value for function j, could not be 0.2. Did you manage to work that out for yourself? If so, well done, that's really impressive. If not, I hope you learned something interesting from this lesson. Please leave me a comment down in the comment section if you need anything clarifying. Otherwise, keep practicing, and I'll see you soon.